Okay, like you heard, my name's Michala. I'm going to talk about an eclipse map I made while working at the Scientific Viz Studio, or SVS, at NASA Goddard. And since this is Practical Cartography Day, I'm trying to make the talk practical by sharing a few tips and ideas I learned while designing this map. First off, I wanted to ask the room how many people in here have made an eclipse map or worked with eclipse data. If you want to raise your hand. See, it's not that many. Like at the beginning of this project, I got the sense that this number was small, you know, as I'm Googling examples to copy, not copy, for inspiration, because I've never worked with this data before, and I do that like most maps I make for ideas. But anyway, at the SVS, I'm the only cartographer, so I was asked to make this map to promote the 2023 and 2024 solar eclipses. And the goal was to highlight the path and show them both on the same map. So I was handed the reign of map making by my wonderful SVS coworker, Ernie Wright, who actually calculates the eclipse data. He's one of the few people, I think there's like two, maybe more, that actually calculate it. He uses moon elevation data from the Lunar Reconnaissance Orbiter, elevation data from Earth, you know, SRTM like we use, and then many other variables that I don't understand. And he turned them into shapefiles for me so I could use. And I think he exudes the font that I chose more than I do. It's like a pretty sick picture. So anyway, I wanted to just overview the eclipse data because I think, you know, it's a cool thing to learn about. And it was one of the main challenges of this project because there's a lot of data, and there could be even more if Ernie gave me all the data he could possibly calculate related to the eclipse. So yeah, and I have to show them both on the same map, which was an ask, not like a must, but I wanted to accept the challenge of trying to show them both, which meant a lot of intersecting lines everywhere. So I'm going to replicate the beginning of a project when you're just throwing all the data into your mapping software and everything's in random colors. It can be an exciting time or an overwhelming time. So you have the path of totality or annularity, which is the path swept out by the moon's shadow. You have the center line of the shadow. Duration is how long annularity or totality will last if you're standing in that eclipse path. And then the umbras, which are the moon's shadow, they're at 5-minute intervals, but I have them at 1-second intervals. And together, they look like a long, bumpy tube, because the umbras are actually bumpy because they take into account the moon's elevation and Earth's elevation. You can download them for yourself and see the tube, but I'll have more on that at the end. And then you have the penumbras of contours of maximum partial obscuration, which means the percentage of the sun covered by the moon. And then double all that for this project. And then a little bit of context about eclipses. You know, when the moon passes between the sun and the Earth while being on the same orbital plane, that's when you have a solar eclipse happen. And sometimes that moon is farther away from the Earth, therefore it doesn't cover as much as the sun's surface, and that would be an annular eclipse. And then the same kind of thing, but this time the moon and its orbital track is closer to the Earth, and it will cover more of the sun, and it actually covers all of it for a total eclipse. So yeah, the one on the right is the annular, and the one on the left is the total, which is happening next year on April 8th. And then the annular one is this Saturday. So I'm leaving NACIS to go back to Oregon. Okay, now that I've introduced you to the eclipse data, I want to restate the map goals, which would show both eclipses draw attention to the path, make people want to go to the path, not just, I'm good where I am because I'll see something, and then incorporate NASA data where I can. And to reach these goals, I wanted the map to be, I was supposed to show the words. To reach these goals, I wanted the map to be clear, beautiful, and helpful to viewers. And to do this, my main strategy would be building visual hierarchy, as you can see how I demonstrated with the clear, beautiful, and helpful. The starting point is a good base. Like I mentioned, I'm supposed to use NASA products making this map, so I knew I'd probably be using blue marble, which is a global image of the Earth mosaic together by satellite imagery. And this data was taken by the MODIS sensor on the Terra and Aqua satellites. It's a great resource for Earth imagery, and it even comes in monthly iterations. And I feel like some people that made this are probably in this room, or I saw that they were coming to NACIS. However, as you can see, the original blue marble is pretty dark, and it would be difficult to put all those vectors and shapes on top of it. It would limit the spectrum of light or color for the text that I would use. Like this would be light gray and white versus, opening that range up significantly if I add some adjustments. And I went even lighter. It looks like bad right now, but it looks different at the end. And then obviously this made the ocean perfect, like it's good to go. But yeah, I brought in some ocean coverage and then shaded Mexico and Canada. And at this point, I thought this was my base, but I wanted something to really pull people in. So throughout the design process, thinking of that goal to make people look at the path, and then visiting the Visible Earth webpage with all this imagery, I came up with an idea, and I came up with it at last year's NACIS. I decided to add imagery from NASA's black marble, or Earth at night, to the paths. And it kind of looks like stars, which would actually be visible during the 2024 total eclipse in the sky. So this is why I limited it to just a 2024 path. And now this is how my base map turned out, and I'm pretty happy about it. And then when designing, so the next step is all of the vector layers I'm going to put on top of this raster. I realized that there's a lot of contrast in this image with the dark ocean, the bright land, the dark paths, and then the dark-ish Mexico and Canada. It would make legibility difficult if I didn't do something about that, because all these layers would be laying on top of this. So I had to break them up in order to change their colors and build that visual hierarchy. And this is what I'm calling vector geoprocessing tools for cartographic design. And I'm going to show you some examples of that zoomed in on the map. So I decided to try to trick your eye and make you think the Great Lakes were under the eclipse path, but they're actually sitting on top by clipping them and changing their color. And I use those tools in QGIS, or you could use the clipping mask in Illustrator. And with this map, there is a lot of doing this, like breaking up the data and recoloring it. Here's lakes in Canada, made them darker blue, but they're actually sitting on the same plane as the light blue lakes. And then again with the 2023 penumbra lines, which are in yellow, which don't really have anything to do with the 2024 solar eclipse and where the purple umbras are. So I clipped them again and made the ones over the ocean a light gray. And then I also clipped the ones that are actually crossing the 2024 path, because they have nothing to do with, that path. And I changed them to a darkish gray. And then the same thing on Mexico and Canada. So in my opinion, if I didn't do that work, it wouldn't take this map to a next level of design for building visual hierarchy, and making a clear, understandable map that draws attention to the eclipse paths. And then here what it would look like if I didn't do any of that clipping, or, like I had already made the base map. I don't want to now go back and add layers onto my vector data. And then for fun, here's what like the original blue marble would look like if I had not made any adjustments. And that concludes a peek into my design process for this map. But I have a request that you go to the SVS site and download this Eclipse data that Ernie, spent a lot of time making, and make your own Eclipse map so that when we Google for visual inspiration, there's more to pull from. To copy, no. And yeah, like I said, the 2023 annular eclipse is this Saturday. And we also have this interactive map that my coworker at the SVS made. And here's what Pittsburgh's stats are. I have the link under there and at the last slide. Yeah, I think that concludes my talk. But one more thing, I broke the map gallery rules, and brought a giant poster of the Eclipse map. So if you want a closer look at all the detail, I encourage you to check it out. So thank you.
Rules are meant to be broken, especially when it comes to maps. Any questions? Yes. Oh, let me bring this over to you.
Michala, this is awesome. I'm kind of excited, except that I'm going to miss it. I'm very sad. But can you say just like which, you mentioned QGIS, was that did you do it all in QGIS, or were there other softwares that you were using for some of this?
I worked in QGIS with all of the raw data, and I kind of export that to Illustrator, like the shapes. And then for the imagery, I did all of that in Photoshop.
Any other questions? All right. Thank you so much, Michala.